Good evening, Prabhakar. Can you hear me? Am I visible and audible to you? Yes? Okay. So, good evening. So, let us wait for, yes, thank you, thank you. So, let us wait for 1 or 2 minutes and then we'll start the class, okay? Okay. So, Prabhakar, you are from which place and which JNV you belong to? Okay. Fine, fine. Okay, okay. So I think we can start the class from Assam. That's great. Good. Belong to a Shillong region, I think. Right. Yes. So is my screen visible to you? Just let me know whether my screen is visible to you or not. Yes. Okay, Prabhakar. I think we can start the class. So we were dealing with aldehydes and ketones, carboxylic acids. And and yesterday we have completed the preparations of carboxylic acids and physical properties and the structure of carboxyl group and the acidic nature of carboxylic acid parts and all. Okay. So today we are going to continue with chemical properties of carboxylic acids. Okay. So the reactions involving the breakage of COH bond and the reactions involving the COH group as a whole, substitution reactions, and then uses of carboxylic acids. So this is what we are going to do today. So coming to the first topic, which is the reactions involving the breaking of COH bond in carboxyl part. That is, we have what is the functional group for carboxylic acid? Just a second. Yes, the functional group for carboxylic acid is R C double bond O OH, right? So in this carboxylic acid, we are going to see the reactions involving the breakage of this carbon-oxygen bond. Okay. So yesterday we have seen about the reactions which involves the breakage of this OH bond, and today we are going to deal with the CO bond cleavage. Got it? So the first reaction involving the breakage of COH bond is the formation of anhydride from the carboxylic acid. Okay. So let us try to prepare the anhydride from carboxylic acid. So I took 2 moles of carboxylic acid of formula RCOOH, and I'm going to treat this carboxylic acid with an acid in presence of P2O5, or if you are using H+, just heat it. Okay, so P2O5 is the dehydrating agent. So who is this P2O5? It is a dehydrating agent. So what is meant by dehydration? It is the removal of H2O, right? So from this 2 moles of carboxylic acid, H2O molecule is going to get removed. So we are removing the H2O, and you see from 1 mole, the CO bond gets cleaved. So this is the reaction. And with the elimination of H2O, anhydride is formed. So what you do, you just connect this oxygen to the carbon, to this carbon. Okay, you will get RCOO, which is called as acid anhydride with the elimination of water. Okay, so if the R group is CH3, what is name of the anhydride I'll get? If the R group is CH3, this is the first carboxylic acid, which is called as ethanoic acid, and this is the second molecule of the carboxylic acid. Okay, so from 1 molecule of carboxylic acid, the carbon-oxygen bond breaks. And what happens here? We have to remove the water molecule in presence of acid or in presence of a dehydrating agent called P2O. So what we will get here? We'll get CH3, C double bond O, C double bond O, and CH3. Okay, with the elimination of water. So what is the name of this anhydride? So since we are taking ethanoic acid as the reactant, we are ending up with ethanoic anhydride. So this is called as ethanoic anhydride. Got it? So this is how the reaction is very easy and it is very simple. Okay, just you have to find out the reagent. That just you have to find out that P2O5 is the dehydrating agent, and it will remove the water molecule from the 2 molecules of acid. Got it? That is the concept you are getting from this reaction. So is the reaction clear to you all? If it is clear, just type S. I'll move on to the next reaction. Two more people have joined, I think. If the reaction is clear to you, just type S in the chat box or just give me a thumbs up. I'll go for the next reaction. Okay, fine. I'll go for the next reaction. That is esterification. So we are going to prepare ester from carboxylic acid. Okay. So how do we prepare the ester? Take 1 mole of carboxylic acid and another molecule of alcohol. So acid plus alcohol in presence of acid gives an ester with the removal of water. So here, this part is the carboxylic acid part, and this is the alcohol. So when acid reacts with alcohol in presence of acidic medium, it forms ester and water. So this is the general reaction. Okay. So from the acid, the CO bond gets broke, and what we are getting? We are getting RCOOR dash. That is ester. Got it? So let us see an example for this. I'll take R group as CH3. If I take CH3COOH as the carboxylic acid, and if I take C2H5OH, that is if I am taking ethanol as the alcohol. So in presence of acid, what I'll get? The CO bond cleaves, and with the removal of this H2O, I'll get an ester of formula CH3COO C2H5. This is called as ethyl ethanoate. So the name of this, sorry, just a second. So the name of this ester is ethyl. The name of this ester is ethyl ethanoate. Okay. And the H2O will be removed. So is the reaction clear? Is esterification clear to all of you? If it is clear, just let me know in the chat box. We will move on to the next reaction. Just type S in the chat box so that I can understand you are listening and it is clear to you. Okay. Can any of you let me know in the chat box? Okay. Okay, fine. So coming to the third reaction, that is a reaction with phosphorus chloride or thionyl chloride. Okay. So we do have two different phosphorus chloride. One is PCl3 and the another one is PCl5. And here we are going to use both. And the thionyl chloride formula is SOCl2. Okay. So what we are doing, we are taking the carboxylic acid first, and in presence of PCl3 or PCl5 or SOCl2 in presence of a base called pyridine. Here pyridine is acting as a base for the reaction of acid with SOCl2. Okay. So you have to take either of these three reagent to get reacted with this carboxylic acid. Okay. So here what happens? The OH group will be converted to the Cl group. So from where does the Cl come? It comes from the PCl3 or PCl5 or SOCl2. So those three reagents are the source to provide the Cl group. Okay. So what is the formula for the product? It is RCOCl. It is RCOCl, which is called as acid chloride. And among these three reagents, SOCl2 is preferred. Why? Because from SOCl2, we get two byproducts. That is, if you are treating this acid with SOCl2, so you get an acid chloride plus SO2, sulfur dioxide as one of the byproduct and HCl as the another byproduct. Okay. So these two compounds, that is SO2 is also a gas and HCl is also a gas. So what happens? So the container is open and here only we are doing the reaction. Since the container is an open container, it is an open system, both the gases goes out. Okay. And we will have only the acid chloride part left out in the reaction mixture. So that we no need to do the separation part if you are doing the reaction with SOCl2. You can directly get the pure compound from the system. Okay. But if you are using PCl3 or PCl5, you will get some byproducts. Suppose if you are using PCl5, you will get the POCl3 as the byproduct. Okay. So in that case, what happens? We have to do the separation technique. We have to separate both the compounds. That is acid chloride and POCl3, we have to separate. For that, you have to go through the separation techniques and all. It takes time. Okay. So that's why SOCl2 is preferred, since both the gases can easily escape from the reaction mixture. Got it? So the most favorable reaction is the reaction of acid with SOCl2 to get the acid chloride. Got it? The third reaction clear to you all? Just give me a thumbs up or it is clear to you in the chat box. And move on to fourth reaction, next reaction. So the next reaction is reaction with ammonia. Okay. What is the formula for ammonia? It is NH3, right? So take the carboxylic acid and treat it with ammonia. So here we are getting ammonium salt. So how we are getting this ammonium salt? So nitrogen has one lone pair of electron. Nitrogen has one lone pair of electron. It goes and attacks this H plus. So here the OH bond cleaves and it goes to O. So basically RCOO minus and NH4 plus ion you are getting. Okay. So can you understand? I'll just write for you. It is RCOO H and NH3, right? So the lone pair on oxygen attacks this hydrogen and the electron shifts to oxygen and we are getting RCOO minus NH4 plus, ammonium salt. And this ammonium salt, so it is RCOO minus and NH4 plus salt, right? And this salt on heating, it forms amide of formula RCONH2. So how we are getting? We have to remove 2 hydrogen from NH4 and 1 oxygen from the carboxylate ion. So what happens here? This carbon-oxygen bond get cleaved. Okay. So with the removal of water, we are getting RC double bond O NH2. So carbon-nitrogen bond is getting formed. And the name of the compound is amide. Just see to an example. So here we took a benzoic acid as an example. R group is C6H5. And on reaction with ammonia, first it would have formed C6H5, C double bond O minus and NH4 plus, right? And then this compound on strong heating, with the elimination of water forms an amide which is called as benzamide. Okay. And amides on further heating with P2O5 gives nitriles. What we have to do? Take this amide and treat it with P2O5. P2O5 is the dehydrating agent. And on reaction with this, it forms nitriles. So I'll go to the next slide. Okay. Amide with P2O5 forms nitrate. It is given here itself. Okay. So here, H2 and O, water is getting eliminated. And we are getting the triple bond between carbon and nitrogen, which is called as nitrile. Okay, this compound is called as nitrile. Got it? Students, if all the reactions which is given here in this slide are clear to you, just let me know in the chat box it is clear. I just want to make sure that you are all listening and the concepts are getting clear, because nobody is responding. Just give me a thumbs up or type it in the chat box. Prabhakar Giri, are you there? Nandini, Sri Kumar, Bhaskar, and yes? Okay, thank you. Thank you, Sri Kumar, you are there. Prabhakar is there. Yeah. Thank you. Got it? Okay, fine. Thank you. I wish you guys could interact. Okay. Okay, I'll move on to the next reaction. Okay, before that, I will do a concept test based on the voice permission is not allowed here with Avanti fellows in this class. Okay. If you want to ask anything, just type it in the chat box. Okay. If you're having any doubt, just put it in the chat box. Fine. So we'll go for the concept test. So students, just identify A, B, C in the following reaction based on the reaction which we have discussed at last. That is the reaction with ammonia. So this is the dicarboxylic acid given to you, and it is getting treated with ammonia. So what is A? A is C6H5, COO minus NH4 plus. So both the hydrogens are getting replaced by NH4 plus ion. So this is compound A. Okay. And then this compound on heating, what happens? Water gets eliminated. So H2O from the first part and from the second part. I'll remove like this. It gets eliminated like this. And the compound B looks like this. It is RCO, NH2 and CO, NH2. Okay. So this is compound B. This is compound B. And compound B on strong heating. Still you have to heat it further. So here what happens? NH3 is removed. NH2 from one carbon and H from the NH2 group of the other carbon goes out as NH3, and this carbon is now going to form the bond with this nitrogen. So what you will get? So this is the compound phthalic acid, which is a dicarboxylic acid. It is treated with 2 moles of ammonia and it forms an ammonium salt. It forms an ammonium salt And this ammonium salt on heating forms an amide, and this amide on strong heating forms a cyclic compound, which is called as thalamide. This compound is called as thalamide, and this thalamide is used to prepare the primary amines. So primary amines have the formula RNH2. So we are using this thalamide to prepare amines, primary amines. So that reaction you would have studied in the amines lesson, okay? And this is the compound A, and this is compound B, and compound C is thalamide. Got it? So I'll move on to the next concept, that is the reactions involving the COOH group as a whole. The whole group is getting converted to some other compound. Okay, here no CO bond or OH bond cleaves. So the first reaction under this is the reduction of COOH group. So to reduce the carboxylic acid group, we have to use the strong reducing agents called lithium aluminium hydride or hydrogen in presence of platinum or nickel, which is called as catalytic hydrogenation, or B2H6 in presence of acid. What is B2H6? It is diborane. Okay. So you use any of these three reagents. So if you use any of these three reagents, the COOH part of the carboxylic acid gets converted to the primary alcohol. Okay. So the conversion is COOH is getting converted to CH2OH. So you have to keep track of the number of carbons in the reactant and product. Okay. So which is a primary alcohol. So let us see an example. So I took propanoic acid here. Propanoic acid has 3 carbons. So treat it with lithium aluminium hydride in presence of ether and H+. Ether is a solvent. And in acidic condition, what do we get? We get propanol, 3 carbon containing alcohol, which is called as propanol. Okay. And the sodium borohydride does not reduce the carboxylic acids, esters, and epoxides, nitro compounds, and nitrates. But it reduces carbonyl compounds and acid chlorides. It reduces carbonyl compounds and acid chlorides. So you cannot use sodium borohydride to reduce the carboxylic part. Okay, it is an exception. Just take a note of it. Sodium borohydride cannot reduce COOH, carboxylic acids. Got it? So is the reaction clear to you? Shall I move on to the next reaction? Okay. So we'll solve a question. So in the reaction, you have to find out C. So to find out C, we have to find out A and B, right? So first, ethanoic acid is taken as the reactant here. And ethanoic acid is treated with lithium aluminium hydride. So who is this lithium aluminium hydride? It is a reducing agent. So what it will do, it will reduce this carboxylic acid part to alcohol, primary alcohol, right? So we'll get CH3, CH2, OH. So this is compound A. And compound A is treated with PCl5. So what is the role of, you want to, which slide? Previous slide? Is this the slide you were asking? Okay, okay. Yeah. Just take a screenshot of it, or you can note it down. The person who was sitting behind the name 12th class, I couldn't find you in the yesterday's class. What happened? You're from JNB Vishakhapatnam, right? Have you joined the yesterday's class? Yeah. You were not there in the yesterday's class? Huh? Okay. Have you noted it down? Shall I go for the next slide? You went with medical issue. Okay, okay, no problem, no problem. No problem, my dear. Yes. So this is the reaction we were discussing. So this ethanol on treatment with PCl5. What is the role of PCl5, students? The OH group will be converted to Cl, right? So we will get CH3, CH2 and Cl. This is compound B. And compound B is treated with alcoholic KOH. So what is the role of this alcoholic KOH? It removes the beta hydrogen from the reactant. So who is the beta hydrogen? The carbon which is next to this chlorine group is called as alpha carbon. And this carbon is called as beta carbon. And the hydrogens which are attached to this beta carbons are called as beta hydrogens. So I'll write the structure like this for your understanding. So this is CH3 and this is CH2. And here is our chlorine and this alcoholic KOH, K plus and OH minus ions are there, no? So alcoholic KOH, OH minus ion will go and attack this hydrogen and the bond shifts here. CCl bond gets cleaved. So we are having CH2 double bond CH2. So since this OH has took this H and they are going out as H2O. And this chlorine which is going out will combine with the potassium and goes out as KCl. So the main product is CH2 double bond CH2. Okay. So this is compound C. And this elimination is called as beta hydrogen elimination, which you would have studied in your class 11 and in class 12 haloalkenes and haloarenes lesson also. Okay. So you should be very careful here. Only in presence of alcoholic KOH elimination occurs. In presence of aqueous KOH, what happens? In presence of aqueous KOH, substitution occurs. Okay. Alcoholic KOH leads to elimination and aqueous KOH leads to the substitution. Got it? So we are asked to find out the product C, and the product C is ethylene. Product C is ethylene. So option 1 is the correct answer for this question. Okay. Shall I move on to the next slide? Shall I move on to the next slide? Just let me know. Yes, thank you so much. Yeah, the next reaction is decarboxylation. So what is decarboxylation? It is the removal of Na2CO3. Removal of sodium carbonate is called as decarboxylation, or removal of carbon dioxide also. Okay. So here we are taking the carboxylic acid and it is treated with NaOH and CaO. So what is the name of this mixture? NaOH plus CaO mixture is called as soda lime mixture. It is called as soda lime mixture. And from here, yeah, it is soda lime. Good. Soda lime mixture, and from here, sodium carbonate is removed. How does it get removed? Na2 sodium hydroxide we are having. So Na2CO3. Na2CO3 is getting removed. Okay. And this R group forms the bond with this hydrogen. So we are getting RH, which is called as alkane with the removal of Na2CO3 and H2O. And this is the soda lime process. This is called as soda lime process. Okay. So let us, have you all noted it down? Let's see an example to understand this. We have noted down the reaction. I'll go for the next slide. Shall I go for the next slide? Yes. So take this as an example. Ethanoic acid is taken. Yes. And it is treated with NaOH and CaO. So can you name the product that we get from this corresponding ethanoic acid? Can any of you type it in the chat box, the name of the product from the given reactant? From acid we are getting alkane, right? So just type the name of the alkane. So here is your R group, methane, Yes, that's great. Your answer is correct. So we are getting methane. So R group is CH3 and to this R group hydrogen is attached. So CH4 is methane. Good. And benzoic acid is taken in the next example. So find out the name of this, the product formed in this reaction. So what we will get basically, we'll get C6H6, no? What is the name of C6H6? It is benzene. We'll get benzene. So whatever might be the reactant, you take the R group and attach it to with hydrogen. You will get the product. Yeah, benzene. Good. So I'll move on to the next reaction. So the next reaction is Kolb's electrolysis. Next reaction is Kolb's. So under this COOH molecule as a whole, the first reaction was reduction, second is decarboxylation. And under decarboxylation, we are studying this reaction. First is the reaction with soda lime. Yeah, Devan, you have raised your hand. Yeah, we have any doubt? Devan has raised his hand. So, okay. Okay, no problem, no problem. Okay, no issues. So I'll go with the Kolb's electrolysis now. So what is electrolysis process? I have already explained you while discussing aldehydes and ketones, right? We took a container and an electrolytic solution will be there in the container and two electrodes are dipped into it. One is cathode, the another one is anode. The solution, electrolytic solution is basically an acidic solution. Okay. And here you see, we are taking a sodium carboxylic salt. Sodium salt of carboxylic acid. And this sodium salt of carboxylic acid on electrolysis forms RR. So here also we are getting an alkane only, but with the evolution of carbon dioxide gas. Okay, there removal of Na2CO3, here removal of CO2. Both are called as decarboxylation only. But if you are doing electrolysis, then that particular reaction is called as Kolb's electrolysis. Got it? So there we are getting RH and here we are getting RR. Okay. So alkane has twice the number of carbon atoms present in the alkyl group. Alkane has twice the number of carbon atoms present in the alkyl group. Suppose if I am taking the same CH3, COO minus and Na plus of 2 moles on electrolysis, what will I get? What is the name of the product? Can you tell me the name of the product from this part? In the previous reaction on taking this, I got CH4, methane, right? So this for the same reactant, yeah, we get ethane because R group is methyl and we are getting RR. So C2H6 is ethane. Good. Hope it is clear to you. So I think we can go for the next set of reaction. That is substitution reactions of carboxylic acids. Okay. We are going to substitute a group in the COOH part. So under this, the first reaction is called as alpha halogenation. Alpha halogenation. So we are taking a carboxylic acid and we are going to treat it with an halogen. So X is halogen, no? It is Cl2 or Br2 in presence of red phosphorus and in presence of acid. We are getting a compound. So what is this? It is alpha halo carboxylic acid and X can be chlorine or bromine. So why it is called as alpha halo? So the carbon which is attached to the carboxylic carbon is called as alpha carbon and these are alpha hydrogens. One of the alpha hydrogen is getting replaced by the halogen which we are taking. If you are taking chlorine, it is replaced by the Cl. Okay. So since the alpha hydrogens are replaced, it is called as alpha halo carboxylic acid. So the name of this reaction is Hell-Ohlad-Zelinsky reaction, which is otherwise called as HVZ reaction. It is otherwise called as HVZ reaction, which is very important. Okay. Reaction is very simple and easy, but the reaction is important. So let us do a question. using this concept, Helvolat-Zelinsky. So you are asked to find out the compound B from the given sequence of reaction. So first carboxylic acid is taken and it is treated with chlorine in presence of red phosphorus. So this reaction is HBZ reaction, right? So in HBZ, alpha hydrogen will be removed and substituted by chlorine. That's why it is called a substitution. So what is compound A? It is CH3, CH, Cl and COOH. This is compound A. And this compound A is treated with alcoholic KOH. So you all know the role of alcoholic KOH, right? It will eliminate the beta hydrogen. So the carbon which is next to this chlorine group is called as alpha. And here we are having two beta carbons. Here also it is beta, here also it is beta. But this beta carbon doesn't have hydrogen attached to it as it is attached only with oxygen. But this beta, let us take this as beta 1 and this is beta 2. Beta 2, yeah. Option 3 is the answer. Yeah, I'll discuss. Good. So beta 2 carbon has 3 hydrogens attached to it. I'll write the CH3 like this. And OH minus will come and take out this hydrogen. The bond shifts here and the chlorine leaves. So what we will get? We'll get CH2, double bond CH and COOH. Okay. So here option 3 is the answer. Option 3 is compound B. Okay. I hope the question is clear to you all. I'll move on to the next slide. So here is the solution. Yeah. So the second reaction under substitution is electrophilic aromatic. The first is HBZ and the second is electrophilic aromatic substitution reaction. Okay. So this reaction is there in all the organic chemistry parts. In aldehydes also we have discussed this. Right. And we are taking the carboxylic acid containing aromatic compound, which is benzoic acid. Benzoic acid on treatment with dilute HNO3 and concentrated H2SO4. So what is the name of this reaction? So these two are the electrophilic reagents. And the name of this reaction is called as nitration. As these reagents are nitrating mixtures. And we'll get an electrophile from this nitrating mixture, which is called as NO2+. This is the electrophile that is being generated from this nitrating mixture. And this electrophile will go and substitute one of the position. To which position it goes and attacks? Can you tell me? Can you tell me whether it goes and attacks to ortho or meta or para? It goes and attacks which position? What type of product we will get? Ortho product or para product or meta product? Can you guess? Meta? Yes, that's correct. So why it is going and attacking the meta position? Why it is going and attacking the meta position? This carboxylic acid group, COOH group, is an electron withdrawing group. It is an electron withdrawing group. So that's why the incoming electron, correct. If an electron withdrawing group is attached in the ring, incoming electrophile goes to the meta position. That is the correct answer. Okay. So our electrophilic aromatic substitution is this. So we have completed all the chemical reactions under the carboxylic acid topic. So do you have any doubts from the reactions which we have discussed? Have any doubts from the reactions? Students, if you're having any doubt from the reactions which we have discussed, you can let me know in the chat box. No doubt? Okay. May I know your name, please? The person who is behind the 12th class ID. Can you just let me know your name? Sandeep. Okay, okay. Okay, Sandeep. So we can, how can we identify electron withdrawing group? Is the question arise from Bhaskar. Okay, I'll tell you. So in the previous classes, I have discussed about this. The electron withdrawing groups are NO2 group, CHO group, COOH group, and COR group, that is COCH3, or that means if you can take an ester, etc. So all these groups are electron withdrawing groups. So if any one of these groups is attached to the ring, the electrophile will attack the meta position. Okay. CN group, cyanide, and what else you can take? You can take ketone, anything you can take. So they are electron withdrawing groups. And the electron donating groups are all the halogens, chlorine. Basically, chlorine will be used as the halogen. You can see this in the alkanes and haloarenes lesson, right? Yeah, all the R groups, alkyl groups means toluene. You can take, if it is a halogen, it is chlorobenzene, toluene, ethyl benzene, propyl benzene. Yeah, alcohol, phenol. If OH is attached, then the particular aromatic substance is called as phenol. You can take NH2. If NH2 is attached, it is called as aniline. Got it? So all these OR, you can take OR. OR is alkoxy, OCH3, OC2H5. So alkoxy groups. All these are electron donating groups. All these are electron donating groups. Got it, Bhaskar? And in the electron withdrawing list, you can add amides also. That is CONH2. Amides also you can add. Okay. Yes, that's great. So just take down this list. Thank you so much for that. If it is clear to you, then it's fine. So any more doubts? Any more doubts from the chemical properties? So yesterday we have discussed on chemical property, that is the acidic nature of carboxylic acid. And today we have discussed pure reaction, which involves the breakage of CO bond and the molecule as a whole and the substitution reactions. Got it? So shall I move on to the uses of carboxylic acid? If you're not having any doubt, I'll move on to the uses of carboxylic acid. Yes. Methanoic acid is used in rubber industries, in leather industries, for electroplating. What is electroplating? Coating a metal with some solution to avoid rusting. Okay, that is called as electroplating. So in that solution, methanoic acid is used as one of the component. And in dye industries also, methanoic acid is used. Ethanol and propanol, they were also used in the dye industries, and methanoic acid is also getting used in the dye industries and in textile industries. Okay, so all these 5 uses are the uses of just the only one compound, which is called as methanoic acid. Okay, just take it down. Just take a screenshot. And coming to the next acid, which is called as ethanoic acid. Ethanoic acid is used as a solvent. It is used as a solvent purpose. And in the vinegar, which we use in our homes, we use vinegar to preserve all the pickles and all. So in that vinegar, we are using the ethanoic acid. And sodium benzoate is used as a food preservative again. Sodium benzoate formula is C6H5COO. So that is used as a food preservative, which is a sodium salt of benzoic acid. And higher fatty acids are used for manufacture of soaps and detergent. So higher fatty acid means more than 15 carbon, more than 25 carbon containing carboxylic acid. So those fatty acids are used in the preparation of soap, which is the preparation of soap reaction is called as saponification. No, and that reaction also you might have seen the salt of this carboxylic acid and in the detergents, which we are using in our cooks. Okay. And esters of benzoic acid, they are used in the perfume industry. So esters are basically they give a sweet smell, no? They give a good fragrance. So what they are doing, they are using it in perfume industry. Okay. So I think we can conclude the today's class. So is there any doubt here in the uses? I don't think you will have doubts in the uses part. So I'll just summarize the today's class and this whole lesson. I'll summarize the today's class part alone, and with today's class, the lesson gets over. Okay. So I'll just note down the important reactions along here. So first reaction is esterification, which were discussed in the cleavage of CO bond, formation of ester, alcohol plus acid forms ester, we have seen, and the reduction of carboxylic acid. So this reaction we have seen under the molecule as a whole, right? The whole molecule gets converted, the whole COOH group gets converted to CH2OH. Under that topic we have discussed how to remember the name reaction. Okay, what I'll do, I'll just share you a PDF, or I'll just share you few reactions which contains only the naming reaction alone. Okay, I'll just share you the name reactions PDF. You can go through that. Is that okay? Just remind me in the next class. I'll share you the naming reactions PDF. In that PDF, you can find all the name reactions which are occurring in all the organic chemistry lessons. Okay. I'll just share it for you all. And I'll let you know in the next class. Okay. Who asked the PDF? May I know the name of the student? I think it is Prabhakar. Is Prabhakar? Who asked me the... Yes, yeah. Just remind me in the next class, okay? I'll just tell you. I'll just send you. And the first reaction we have seen in the RC double bond OH cleavage, where CO bond breaks. Esterification. And third one, also we have discussed under the same topic, the whole COOH is getting converted to hydrogen. And what is the name of this reaction? This is called as decarboxylation, right? This is decarboxylation with soda lime mixture. And the second is also called as decarboxylation, but with electrolysis. Here, COONA part is getting converted into R. That is 2 moles of R you'll get. Yeah, Shrikruti is joining after long time, it seems. Shrikruti is joining after long time. Yeah. What happened to you, Shrikruti? Good evening to you. Now we are at the end of the lesson. I am discussing the summary. So the last reaction for today's session is, what is the name of this reaction, students? Can you find out the name of this reaction? This reaction we have discussed in the substitution reaction of carboxyl. You are sick for a few days. Are you all right now? Are you all right now? I hope you are fine. Yes. Thank you, ma. Take care of you. Okay. Nandini, you are great. HVZ reaction is the name of this reaction. Good. So this is HVZ under the substitution. So these three are the topics which we have discussed, and these are the very important reactions under each title. Okay. So students, if you are having any doubts in this lesson, just go through this lesson, study the lesson again and again. The aldehydes, ketones and carboxylic acid lesson is very, very important. Little bit big, but all the reactions are very easy. Conceptual understanding is very important. Okay, don't just memorize all the reaction. Just try to find out the conversion alone. Like for example, in decarboxylation with soda lime mixture, I'm getting RH. In electrolysis, I'm getting RR. Like that you study. Don't just simply memorize CH3COOH plus NaOH forms CH3H. Like that, don't memorize, just understand. Okay. Only the conceptual understanding will fetch you good marks in your competitive exams, whether it is NEET or JEE. Okay. Study the lesson. If you are getting any doubt, you can feel free to ask me on Monday or in the next class. Okay. So in the next class, I'll move on to a new lesson, which is biomolecules. Biomolecules I'll discuss in the next class. And for tomorrow and day after tomorrow weekend class, we'll solve some questions from this aldehydes, ketones, and carboxylic acid lessons. Okay. Students, is that clear? If you're having any doubts, now you can ask me. We have few more minutes also. If you're having any doubts, you can ask me. If you're not having any doubt, I'll just close the class for today. If it is clear, just type it in the chat box or raise your hand, give a thumbs up. I'll close the class. No doubt. Thank you so much, Sandeep. Thank you. Okay then, students. I'll meet you in the next class. Bye-bye. Thank you. Take care of you. All of you take care. Thank you. Thank you. Thank you, Ma. Thank you so much.